Okay, in this question we've got the matrix A that's been defined by this over here. We've got -1, -√3, √3, -1. And what we need to do to start with is we need to calculate the matrix A squared. So part A, I need to work out A squared, which I know is going to be this multiplied by itself. So I'm going to write that out, -1 √3, -√3, -1. Multiply that by itself. And if I multiply this out, I've got -1 times -1, which is 1. I've got -√3 times √3, which is -3. So I've got 1 take away 3, which gives me -2 over here. For this one here, I've got this column, sorry, this row times this column, -1 times -√3, which is √3, -√3 times -1, which is √3. Add those together, I get 2 √3. Over here, -√3, -√3, so that's going to be -2 √3. And over here, I've got √3 times -√3, which is -3, plus 1, so that's going to be -2. Okay, so the value of A squared is going to be that there. Part 2, we're asked to show that A cubed is equal to K times I. So I'm looking for an answer here that's going to give me a multiple of the identity matrix, where K is an integer and I is the 2 by 2 identity matrix. Okay, so A cubed, therefore, that's going to be equal to this A squared multiplied by A. And it shouldn't matter which order I do this in. So I'm going to take this and I'm going to multiply it by this over here. So we've got -2 √3, 2 √3, -2. And I'm going to multiply that by -1 √3, -√3, -1. Okay, so this here, do this row times this column, so I've got 2 plus 2 times 2 √3 times √3, so that's going to give me 6. So I've got 2 plus 6, which is 8. For this one, I've got this row times this column, so I've got -2 √3, positive 2 √3, take away 2 √3, which is going to give me 0. Over here, I've got this row times this column, that's 2 √3, take away 2 √3, which is 0. And then I've got this row times this column, which is positive 6 plus 2, which is 8. So I've got 8, 0, 0, 8, and I can see that that's going to be equal to 8 times my identity matrix. Yeah, my identity matrix will be 1, 0, 0, 1, so that's 8 times as big as that. So the value of K is going to be 8 in this case. Okay, so part B now. And for part B, I'm saying I'm being asked to describe the single geometrical transformation or combination of two geometrical transformations corresponding to each of the matrices. So the first one I'm going to identify it for is A cubed. Okay, so for A cubed, that's this one here. I can see that because this is 8 times the identity matrix, I can see that my points are just going to be enlarged by a scale factor of 8. Okay, so this here represents a an enlargement of a scale factor 8. So I'm going to put that in, enlargement scale factor 8. Okay, so that one was nice and simple. Okay, part 2. I'm now being asked to find what the geometrical transformation is for just the matrix A. So that's just this matrix here. Well, I know A cubed gave me an enlargement of a scale factor of 8. So what's happening here is my shape, there's clearly something else happening along the way, but when I get to carrying out the transformation 3 times, effectively what's happened is that it's grown by a scale factor of an 8. So I know that if I just carry out the 1 time, I can take the cube root of 8, and that's going to give me an enlargement of a scale factor of 2. Okay, so I know that an enlargement scale factor 2 is going to be involved. But there's something else going on as well. And just by looking at the pattern over here, I can see that there's actually going to be a rotation going on. The reason why I know this is because the signs, these two numbers have the same magnitude and are of equal, so the signs are the same. These two here have the same magnitude, but they're of opposite signs. So that tells me that this is going to be a rotation matrix. And I know the rotation matrix, I'm just going to write it over here, is cos theta sine theta, negative sine theta, cos theta. Okay, so I know this gives this is the general equation, the general rotation matrix, what it looks like. So what I need to know is what this angle theta is. Okay, so because I know that there's an enlargement of a scale factor of 2 that's happened, what I'm going to do is, to this matrix here, I'm going to take out a factor of 2. So I'm going to rewrite matrix A as, I'm going to take out a factor of 2, so I'm going to take 2 outside of the matrix, and that means that everything inside I'm going to have to half. So that's going to be negative a half. This is going to be negative root 3 by 2. This is going to be root 3 by 2, and this is going to be negative a half. Okay, so this part here is going to represent the enlargement, and now this part here is going to represent what the rotation is. Okay, so using this here, I know that cos theta is equal to negative a half, and I also know that sine theta must be equal to root 3 by 2. Okay, so I need the solution to both of these equations over here. So if cos theta is equal to a negative a half, then theta is going to be equal to, and we've actually got two solutions here. We've got theta is equal to 120 degrees, and we can also have theta is equal to 360 take away 120 degrees, which is going to be 240 degrees. Okay, so both of these anti-clockwise rotations are going to work. And over here I've got, again, if sine theta is equal to root 3 by 2, then I know that theta is going to be equal to 60 degrees, but also 180 take away 60 degrees, which is going to be 120 degrees. Okay, so the one that's consistent in both of them is this anti-clockwise rotation of 120 degrees. Okay, so that means that this part here must represent a rotation of 120 degrees anti-clockwise. Okay, so what we've got is we've got a combination of an enlargement of a scale factor of 2 and a rotation of 120 degrees anti-clockwise. Okay, so just this does make sense, because if each time I did this I enlarged by a scale factor of 2 and I rotated 120 degrees anti-clockwise, then by the time I get to a squared, which is this one over here, that would be an enlargement of a scale factor of 4, because 2 times 2 is 4, and it would be a rotation of 240 degrees anti-clockwise, because I would have rotated twice. And by the time I get to a cubed, because the enlargement is a scale factor of 2 each time, 2 times 2 is 4, times 2 is 8, so that gives me that bit there. And a rotation of 120 degrees anti-clockwise, if I applied that 3 times, that would be 240, 360 degrees anti-clockwise, which brings me back to where I started again. So that's so this does actually make sense. Okay, I hope that was useful.